All right, we're going on now to some application problems to our quadratic units. Better strap on your boots here. Let's get a little hairy, a little crusty, crunchy little guy here. But we got this. We're in the NFL. Nerd for life. All right. So here we go. In 1 hour, in 1 3/4 hour, Cody, he rows his boat 5 miles up and comes back, right? So that's 5 miles going up, and he's going to come back down 5 miles. Now, the rate of the current is 3 miles per hour. Okay, now we want to figure out how fast is Cody rowing. Okay, not specifically how fast is he going with the current, just his buffness, like how buff is he really, right? I mean, like, is he a little skinny little dude? Like, is he, is he gonna be able to go fast like up the stream, or is he gonna have to use the current and go downhill? Like a little wimpy little guy. Well, we'll have to find that out right now, right? That's what we're gonna figure out. Like, how fast can Cody row on his own, not cheating with the, with the current there. So we gotta get a little nerdy here. All right, okay. So the first formula that we've learned, or that I'm gonna show you right now, that you've probably seen before, is DIRTS. D equals RT. Okay, D equals R multiplied by T. So that's the distance is equal to the rate multiplied by the time. And this is going to become very important in this problem here. Okay, so Cody here, he's going up the stream. Okay, so like he's going up the stream. Okay, like here he is in his little boat. Hi, guys. Okay, and then he also goes down the boat. Okay, there he goes right there. Okay, so he's going up the stream and he's going down the stream. Okay, so basically we're going to have two equations here, and we're going to use both of them. Okay, so check this out. Let's derive an equation for Cody's distance and his rate and his time based off of him going up the river and him going down the river. Okay, so first of all, what's his distance going up the river? Well, look back at our problem here. It said right here that he travels 5 miles, and that's going up and down. So that means we're going to go ahead and replace the D with 5. So 5 miles. So, okay, right here. So D equals 5. Now the rate at which that he's going, again, if he's going up the river, right? If he's going up the river, then the water is going against him, right? And it's going against him 3 miles per hour. So, check this out here. We're gonna let X equal how fast Cody rows. How fast Cody rows. Okay, so just him alone. Okay, and the reason why that we need to do that is we're gonna now introduce the X variable. Now I'll put this up here. Beep. Okay, so watch this. See if this makes sense here. So that means the rate, I'm going to say, is how fast Cody rows minus 3 miles per hour. Because he's going to be traveling up the river. He's going up the river, but then the current is going against him. So it's going to actually slow him down a tad bit. Unless he's, buff like some guys, he can just go, right past it, but it's still gonna, go against him, right? So that's why, again, X is how fast Cody's rowing, but I'm gonna subtract 3 because he's trying to go up the river, okay? And then I'm gonna multiply that by its time. Okay, so my distance is 5, my rate is X minus 3, and my time is just T. We don't know how much time it is, okay? We're gonna figure that out here in a minute. Now, what about him going down? Distance equals rate multiplied by time. Okay, so now down, the water is going with him. Okay, it's kind of like a little boosty. All right, he's kind of like, running track and field, man, and like you got the wind behind you, it's just kind of giving you a little booster right there. Usually your times don't really matter now because you got a little cheat sheet right there. So we know that the distance is 5 again. Why? Because it says that it goes back down 5 miles. Now, what about Cody's rate? How fast does he go? Well, Cody's rate is X. Now we're going to add 3 miles an hour. Gives him a little boosty. And I'm going to multiply that by time. Okay? All right, so what I want to do now is this. Okay? Let's represent Cody's time going up the stream and Cody's time going down the stream in representations of x, meaning let's solve for t. Okay, so if I solve for t here, I'm going to divide by x minus 3. Okay, so those are gone. So that means t, this t right here, is 5 over x minus 3. Yeah? Again, this right here is him going up the stream, up. Now, how about over here? Let's divide by x plus 3. And that means his time going down the stream is going to be 5 over x plus 3. Okay, so we have, this is him going down. So we have the time of him going up the stream. We have the time of him going down. Check this out, y'all. If I added up this t plus this t, what's the total time that he was gone? Oh, we got to go back and read from the problem. So right here it says, in 1 3/4 of an hour, Cody rows his boat. Row, row, row your boat gently down the stream. All right. So, hey, maybe I should make a song right there. Okay. Not right now. We're trying to do this math here. So, the total time is 1 3/4. So we can make an equation. We can add this guy plus this guy, and that's going to be equal to 1 3/4. Charlie, man, get on your boots here. It's going to get a little crunchy here. So let's do that. Let's take the time going up. So 5. Oops. Let me get out of highlighter mode. Okay, so we're going to do our first time going up. So 5 over x minus 3 plus the time going down, 5 over x plus 3. And that equals the total time. And the total time, again, was 1 3/4. But we don't want to write it as 1 3/4. Let's write that as an improper fraction. So the way you do that is you multiply the whole number and the denominator, and then you add the numerator. So 4 times 1 is 4, plus 3 is 7, and then you keep that same denominator of 4 there. Okay? All right, so that's the number that I want to set that equal to. Okay, so before we solve this now, let's just make sure that we understand the context of this. This right here represents the time going up the stream. This represents the time going down the stream. So the time it took him to go up plus the time it took him to go down equals the total time. Okay, so hopefully that makes sense in the context of what we're talking about. And now we have to use the skills that we learned earlier in this section, and we have to now solve for x. You're like, dang, man, we're like halfway done. It's been like a 10-minute problem already. That's just the way this problem goes. Okay, so we need the lowest common denominator, right? Good lowest common denominator. All right, let's go and continue on here. Sorry, a little announcement right there. Okay, so the LCD, again, is when you take all the denominators and you multiply them together. So we have one of them is x minus 3. The other right here is x plus 3. And the other right here is 4. So the LCD is x minus 3 times x plus 3 times 4. Okay? And we actually want to leave them in its factor form. Don't multiply these all together, because we want the factors to cross out when we multiply them. Okay, so here we go. Let's multiply everything by the LCD. So everything's going to get multiplied by x minus 3 times x plus 3 times 4. So here we go. So 4 times x minus 3 times x plus 3. And I guess I'll do this in red. Multiply that by 5 over x minus 3. And then we'll do plus the LCD again. X minus 3 times x plus 3. And multiply that dude by 5 over x plus 3. Ooh, Billy. All right, and then lastly, 4 times x minus 3 times x plus 3. Multiply that whole thing by 7/4. So 7/4. Wow. Took up the whole screen right there. Crazy. Okay. Okay. Game on. Had to pause it twice there. Hopefully no more after this. Okay. So let's go ahead now and cross out our common factors. Oh yeah. Oh yeah. So since those are those are crossed out. What I'm going to do here is I'm going to multiply the 4 and the 5 together, and that's going to become 20, and then I have my x plus 3. So on my next line, I'll go ahead and simplify that. So I just decided to multiply my constant numbers first here, okay? Plus, so we can cross those guys. So I'm going to multiply the 5 and the 4. So I get 20 times x minus 3. All right, equals, and the 4 and the 4 cross out. So I'll go ahead and do the FOIL method right here. And if you do the FOIL, you're going to get, in parentheses, you'll get x squared minus 9. So you can kind of do all that work on the side if you need to. All right, well, let's keep pressing on here. We haven't solved for x yet. So I'm going to go ahead and distribute the 20. So 20x plus 60 plus 20x minus 60 equals, then we do the little distributive property. 7 times x squared is our 7x squared, and then 7 times negative 9, negative 63. Okay, so let's see here. The 60s cancel. Sweet. And then we get 40x equals 7x squared minus 63. Will this problem ever end? The answer is yes. And hopefully it ends here in just a few secondos. Okay, so let's subtract 40x, subtract 40x. So we get 0 equals 7x squared minus 40x minus 63. And let's see. I had to sneeze there. Thank you very much if you said bless you. Okay, so it doesn't look like this is factorable. And do you know what that means? The quadratic formula. No. Okay, now that we've done that, let's do the quadratic formula. Dude, this guy's hairy. Man, I didn't make this problem up, guys. Seriously, this is just like in the textbook. All right, here we go. So let's do it. X equals negative b plus or minus the square roots. B squared minus 4 times a times c all over 2a. All right, let's plug this in here. So the b goes right here, so negative 40. Goes right here, our negative 40. Our a right here is 4a times c, negative 63. And then times a. Woo! Bust out your calculator. So x equals a negative is our positive 40. Plus or minus. So let's see here. We'll get negative 40 squared. So we get 1600. Plus, let's see here. 4 and 7 and 63 will give us a 1764. 1764. And I know it's going to be plus because a negative times a negative gives us our positive. And that's all over 14. Okay, I'm hoping this is going to come out to be a nice number there. Let's see. 1764. So x equals 40 plus or minus. Add these guys all up, and we get 3364 all over 14. So let's see. 40 plus or minus the square root of 336 gives us, 58 over 14. Cool beans. Woo! So now let's go ahead and get our two answers here. Okay, so we have our first answer, which is 40 plus 58 over 14. And 40 minus 58 over 14. Okay, so doing all that there. And on this guy, we're going to get 7. And doing this guy right here, just punching this into the calculator here for time's sake. And I'm going to write this as a decimal, negative 1.29. Okay, so if you go back and look at the problem now, now that we found two answers, let's just go back and read the problem. And because since it was a real-life problem, we have to give a real-life answer now, not just a numerical value. So coming all the way back up here, it says, how fast does Cody row? How fast does he row? Well, we come all the way down. Remember how we said here, X stands for how fast Cody rows. So if you come down here, we have two answers. We have 7 and we have negative 1.29. Can you row at negative miles an hour? No, I mean, that don't make sense. So in the context of this real life problem, we actually ignore this problem or this answer, and then we say that the answer right here is 7 miles per hour.